In cases where you want a specific value or dimension to control other parameters in your design, you might find equations or the link values functions useful. In this example, if you'd like the width of the ladder rung to be the same value for the distance mate that positions the bottom rung, as well as the linear pattern distance for all of the other rungs, this can be easily done by using equations that make these dimensions equal to the width of the rung. To do this, I'll show the feature dimensions of the rung by right-clicking the Annotations folder and selecting Show Feature Dimensions. I'll also do this for the assembly to see the dimensions for the distance mate and linear pattern distance. To add an equation, I'll double-click the distance mate dimension. Instead of typing in a value for the distance, notice the drop-down. This is where I can either add an equation or link a value. Linking values can be useful when you want two or more values to match within the same part file, or within the same assembly file. But in this case, since we're trying to link the value from a part to values in the assembly, an equation must be used instead of the link values option. As soon as I select Add an Equation, the equation input box appears. It includes the correct syntax for the dimension name of the distance mate. To make it equal to the rung's width, I'll simply click that dimension, and the proper syntax is added. When adding equations, keep in mind that the dimension you select first to add the equation will be the driven dimension. This means it'll change based on whatever is on the right side of the equation. In other words, it's the dependent variable. Once the equation is added, I'll click OK and repeat the process for the pattern dimension. I'll double-click it, choose Add Equation, and again make this value equal to the width dimension of the rung. Now, while this is a very simple equation, keep in mind there's much more you can do with equations. Perhaps for a simple change, I'll add 2 inches for the pattern distance. So this means the pattern dimension will always be the rung width plus 2. I'll click OK, and in the equation dialog, you can see what each equation evaluates to. I'll close the dialog and rebuild the assembly for the changes to take effect. At this point, if I make a change to the width of the rung and rebuild the model, the equation-driven dimensions will update correctly.